Hello, my name is Brian Genius. This is my final project for Understanding Our Universe, an Introduction to Astronomy. First, my role is I am a central office curriculum leader for a suburban school district around Columbus, Ohio. I serve K-12 science, health, and physical education students and teachers. Most of my role is around resources, instructional support, some coaching, and curriculum alignment. I hope to implement this during a curriculum meeting and when our teachers come in to learn more about and collaborate with one another. We're going to connect this to the next generation science standards with the cross-cutting concepts, science and engineering practices. We are in the state of Ohio, which does not use NGSS, but we have our own set of standards. And my measurement for success would be the actual implementation and observation of some of these aspects being put into the classroom and being used. Some of the challenges are our teachers may think just because they actually teach about the solar system that they already do this. It's not about the content, it's more about the delivery and the student level of engagement. How do we get students doing more work in the classroom and our teachers facilitating that rather than doing it for students? Teachers may also push back on the amount of time this will take, and one of my key phrases is it's always more important for us to have students learn science than for us to teach science. So no matter what, it's about the learning that students are engaged in, not about how much we get through or we say to our students. There's also a challenge when classrooms are particularly heavy in recall type of activities for students. They think that making them think is something students are not capable of doing, and so this challenge may be very real for some of our teachers. But if we give them a reason as to why they need to think and to help solve some problems, we should be able to engage more of our students in the learning. So here's my project on the solar system. It's going to be around the Earth Space Science standard from 5th grade. The solar system includes the sun and all celestial bodies that orbit the sun. Each planet in the solar system has unique characteristics. We're going to use the NGSS cross-cutting concepts, as I said before, as well as the science practices, address that standard, and then model a lesson for teachers. It's going to start with an engagement to try to connect to the humanity of astronomy and talk about the plight of one of the fathers of modern science, Galileo, who really started pointing his telescope at the heavens for the first time, and he made some observations, particularly around Jupiter, where he saw the 4 major moons orbiting, which gave him the idea that there are other solar systems out there, which got him, and the Earth wasn't at the center of all of this, and that got him in trouble with the church, which put him under house arrest. The house arrest, as you can see, was in Florence, Italy. Not necessarily known for its treacherous experience. It is a delightful place to be. You can see he had visitors from this painting, as well as his telescope was still there so he can make more observations. So had he looked up and had a better telescope or other techniques, he might have been able to do what scientists have done recently, and that's find a solar system that's outside of our solar system. So this one's called Kepler 90. It consists of all of these different planets, and this, just a reminder that this is an artist's conception of what this might look like. So what does that mean? I'd go over that with students, as well as that it's a model. So all models have errors in them. So what is the error in this one? And then, for example, planets are drawn to scale, and the distances are not. So I'd go over that. This is from an article in the LA Times. Then we go over the types of planets with the students, the 4 inner planets, or terrestrial planets as they're known because of their hard surfaces. And then some about the outer planets, or Jovian, or also gaseous giants planets because of their surface is primarily gas. This would bring us to the point that those have two different kind of grouping characteristics. So what are the unique characteristics of each of our planets? I'd have our students go research that, bring that information back, and share that with the rest of the class. It's this sharing and negotiation of concepts that is essential for students to feel engaged and part of this lesson, as well as retain this information for future use. We would fill out a chart, something that looks like this, that says, for example, Earth has life on it, is a unique characteristic within our solar system. It also then would prompt them to say, well, what did we find out about how long their year is? So we'd go through that and engage students in finding that information. Well, what about a day? Is that relationship of 24 hours in a day and 365 days per year the same on all these planets? So I filled out, this is kind of the data that you would expect to see, some of the accepted values. Also for the day, some of the accepted values. So with these two pieces of information, the year as well as the day, I'd ask students to draw some conclusions about that pattern. That is an NGSS cross-cutting concept, finding patterns. And what does that mean? And some sample conclusions would be, for example, that planets farther from the sun take longer to orbit the sun than planets which are closer. And from the rotational periods, it does not appear to be a similar relationship. Although you might say Jovian planets rotate faster than terrestrial planets. Some deeper thinking ideas would be to ask the students, why is it important to know this information? For example, if we try to visit Venus, it may be a bad idea to go there without some future information about how hot it is or how much that pressure, it rains acid. It's a very uninhabitable planet in our solar system. So why is Mars a better choice? And what would we expect to find on Mars? And what information will that help us understand Earth better, etc.? So we're going to start going into some more creative thinking. So for example, students could create their own planet in option 1 and then describe how it would fit into our solar system, what location, how far from the sun, what would be its rotational period, why, what's it made of, things of that nature. So we're looking simply that they find the patterns that are essential that we just went over. Students that might need a little more help, you could possibly give them a planet and ask them to place it in the appropriate location, or even use data from an exosolar system like Kepler-90 and have them put those in order based on that information. So speaking of Kepler-90, interesting piece on this, when scientists first found this, they also found out that Kepler-90H, the one that is farthest from its sun, is actually closer to the sun, its sun, than Earth is to its sun. So this should really be condensed down all the way to where Earth is. And what does that mean for a solar system? And how does that change our impressions of what Kepler-90 is? What do we know about how long each of those planets take to orbit the sun? All great questions. Remember, again, these are artist conceptions. That is a mistake. So the two solar systems are not in scale with one another for obvious reasons. And then our final conclusion is really to help our students gather the information so they learn and get that practice doing an open resource sort, identifying valuable information from useless information, and to have them draw conclusions rather than telling them the answers. Again, remember that finding those unique characteristics, each one itself is not essential, but the process is more essential than having them gather the same pieces. And then the assessment will actually come from them, the students' ability to draw conclusions from the information and data that they gathered. So that is all important pieces. So thank you very much for listening. I appreciate any feedback you might be able to give me.